Welcome, boys. We are looking at probably the last chapter. This is the last chapter of this year's lesson 15.1, mean absolute deviation. Mean absolute deviation. This is lesson number 15.1. Now, some of the things that we need to have an idea about before we start. Number one is what is a data set? What is a data set? Okay, a set of data points, which is a typical example for a data set would be, let us say these are the height of the building in a city, 70 feet, 25 feet, 60 feet, 100 feet. Now, this arrangement of data, point by point, is called a data set. All right. Now, let us say there are different, as we all know, there are different heights of buildings in a city. And you want to find out what is the tallest building, what is the smallest building, and what is the building that is of mid size. What you do is you take the heights of all the building, you write it in this form, which is called the data set form. And then you go from there to identify 100 feet, this building would be the highest, and 25 feet will be the lowest. But what is the building that is midway through, which is the center point in height? To find out that, you need to find out what is the center point value. The center point value is a single number which is called the mean. You should be already aware of this concept, the concept of mean. Whenever you deal with a data set, we deal with the concept of mean. Okay. So what is a mean? Mean is a center point. So if you have 70, 25, 60, and 100 feet, okay, what you do is you add the numbers and then divide it by the number in the data sets, or how many data sets are there, how many data points, these are called data points, how many data points are there in the data set. So in this case it will be 1, 2, 3, 4. There are 4 data points, so you divide the sum of the numbers by 4. So for example, in this case it will be 100 plus 60, 160. 160 plus 70 would be 230. 230 plus 25 would be 255. So in this case, it would be 255 divided by 4 will be the mean. Now, what will that come to? 4, 6 are 24, 15, 4 3s are 12, 30, 7s are 28. So 63.7 feet is the mean. Okay. So the mean value, which is the center point value, is equal to 63.7. Now you come back and look at the data points in the data set, and you find out which height or which building, the height of which building is nearer to the mean value, and that will be 60. So which means this is probably nearer to the center point. Now this is how the concept of mean is used. Another concept that we need to be aware about is the acronym for that concept is MAD, M-A-D. Okay, sorry, M-A-D. This is called mean absolute deviation. Now, what does this mean? Mean absolute deviation. Simply, if you go back here, you're trying to find out, this is the mean. Okay, so let us say you draw a data line, and you have 50, 60, 70, 80, 90, 100. Okay. And plot these numbers on this number line. 70 would be here at this point. So we have 70 there. 25 would be behind this. So let us say this is 40, 30, 20. Now, what I'm doing here is I'm looking at the video and explaining, and that's the reason why I'm not having a clear idea of the depth of the distance between my pen and the paper. Therefore, you will see that my writing is slurred. Hopefully, you'll understand that that is the reason why the writing is slurred. Anyways, what I'm trying to say is this. If you look at the first building, you plot the point at 70. You take the second building and it's at 25. 25 would be somewhere here, so you plot it there. That's the second building. Third building is at 60, so you plot it here. Fourth building is 100, so you plot it here. So you have 1, 2, 3, 4. There are 4 data points, and you have plotted the 4 data points on the number line. Now, where is the mean? Mean is 63.7. So let us say this is 65. 63 would be somewhere here, and 63.7 will be this point. So here you have the mean. Now, MAD, which is mean absolute deviation. Okay, mean absolute deviation. What does it represent? It basically gives you a number of how far are each of these data points from the mean. How far are each of these data points from the mean? For example, this data point is 70. This building that is of height 70 is this far away from the mean. On the other hand, this data point, which is the building with 100 feet, is this far away from the mean. Now then you add all of them together and you get again you take the mean of how far are these numbers from the given data points, and you get the MAD value. So here you have the mean. How far is it from 70? So 63.7 is, let us say, let's take this first data point. So you go and you subtract 63.7 minus 70 would be minus 6.3, but you only take the absolute value. That's why you take 6.3. Then you take the second data point. Okay, in this case it would be 100 or 63.7 minus 100. Let's do that. 63.7 minus 100. There you have 36.3. You take the minus 36.3, you take the absolute value, which is 36.3. Then you go to 60 is another point. How far is it from 63.7? It is 3.7. So you add them together. You take the absolute value, and then you go to 25 and do the same thing. 25 minus 63.7. And that is 38.7. So here I have 38.7. You add all of them together, and just exactly as you do, you take the mean of this deviation. Now, what are you doing when you subtract here? You're trying to find the deviation, the distance of each data point from the mean. And you divide it by the number of data points. So 1, 2, 3, 4. You divide it by 4. Let us add them together and divide it by 4. 38.7 plus 38.7 plus 3.7 plus 36.3 plus 6.3, 85, which is 85 divided by 4 is equal to 21.25. So this is the MAD value, M-A-D value of 21.25. It gives you an idea as to, the MAD value of mean absolute deviation gives you an idea of this data set as to how far away each of the data points are from the mean. How far away each of the data points are from the mean. So you have here, what you do is you take the distance from the mean, the absolute value. So even if it comes negative, you just take the positive value. You find the difference. So take the positive value, take it, and then add them together, divide it by 4, and you get a value. And this is how you find the mean absolute deviation. Now, chapter 15.5, 15.1 is basically trying to understand this concept. Let us say, let's take another example. Here you have two data sets, okay? Two data sets. And what you're going to do here is compare the MAD value between this data set. What is the MAD value of this data set? This MAD is an acronym for mean absolute deviation, versus what is a MAD value for this data set. Now, what does mean absolute deviation tell us? When mean absolute deviation is a number. And what does that number tell us? If you have two data sets like this, the number tells us, if let's say you have a number, let us say, I'm just giving an example, the MAD value for this data set is 2.1. And let's say the MAD value for this data set is 3.8. What does this number indicate? This number basically indicates that this data set have values spread off from the mean, has values spread off from the mean, or the spread is much in this case when compared to this case, because the value of MAD value is higher. Okay, so let us look at this, these two data sets. So to find the MAD value, what do you do first? You first find the mean. You basically find the mean. That's what you need to find. How do you find the mean? You basically add the data points together and divide it by the number of data points. So in this case, it'll be 2 plus 2, 4 plus 4, 8. 8 plus 4 is 12. 12 divided by number of data sets, that'll be 1, 2, 3, 4. That's 4. And what is the mean? 3 is the mean. Now, what does it mean here? Let us look at the data points. Here you have 1, 1, 6, 4. So 1 plus 1 is 2. 2 plus 6 is 12. 2 plus 6 is 8. 8 plus 4 is 12 again. That is 12 divided by 4. And you get the value 3. So here you have mean is basically the same in both these data points or data sets. Now we'll have to represent, let us represent this on a number line to just have an idea, okay? Here you have a number line. 1, 2, 3, 4, let us say this. Now, you represent 2 here. 2 data points are 2, and 2 data points are 4. What is the mean value? The mean is, this is the center. Okay, this is the mean of this data set. So it means, what does this indicate, or what does mean? Mean is basically the center point of these data sets. Okay, that's what it does. Let us plot this on a number line. These data set on number line. Here you have, now in this case you have 6 and 4, so you may need to, and also 1, so you may need to go from 1, 2, 3, 4, 5, 6. There are 2 1s, so you plot those 2 data points there. 1, 6, so you plot that data set there, and 1, 4, you plot that data point there. And then what does it mean? 3 is the mean, so this is the center. See, if you look at these plots, this number line plots, you see that these data points, this set of data points and this set of data points are kind of equidistant from the mean. But in this case, you see that this data point and this data point are further away. You see 6 is further away from the mean. So MAD gives you a number as to how far away or spread out are the data points with respect to the mean. And in some problems we have to find it. Now we'll have to go find what is a MAD value. Okay, now what is a MAD value? You take the difference, absolute value. In this case, 3 minus 2 is 1, plus another data set, right? There are two data sets. There are two 2's in the data point. So the mean is 3. So subtract mean from the data point. So 2 minus 3 is 1. Again, you neglect the negative. You don't take the negative. You neglect the sign. You just take the absolute value. And then 3 minus 4 is 1 minus 1, but you take the absolute value. And then you have another 3 minus 4 is 1 absolute value. They're divided by number of data points. That is 4 by 4, which is equal to 1. Okay, so 1 is a MAD value here. In this case, what is a MAD value? 3 is a mean, and you take the distance between each of the data points from the mean. Okay, you take the distance between each of the data point from the mean. So let us do that. Okay, 1 minus 3 is 2. Okay, you don't take it's minus 2, but you just take the absolute value without the sign. Then 1 minus 3 is again 2, minus 2, but you take the absolute value. 3 minus 6 is minus 3, you take the absolute value. And 4 minus 3 minus 4 is minus 1, you take the absolute value. Divided by number of data sets, that's 4. So 2 plus 2 is 4, 4 plus 3 is 7, plus 1 8, 8 by 4, which is 2. So this is the MAD value for this data set. This is the MAD value for that data set. Which number is greater, 1 or 2? Of course, 2 is greater. So which means what? In this data set, there are points that are spread away from the mean. That's what it indicates. So in this chapter, mainly we're concentrating on mean and the mean absolute deviation. The definitions are given here. I've done 2 problems to show how it is. Here, let us read this question. The data represents the height in feet of various buildings. Find the mean absolute value for each data set. First of all, what do? You calculate the mean. So you add all the numbers and then divide it by the number of data points. So you add these numbers and then divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. Then what you do is, you need to, let's say you get a value of the mean here. Then you take the mean and subtract it from this to find the distance, how far are each of these points from mean. And then what do? You take this value and divide it by 10 again to get the MAD value. So you'll have to do this for the homework. Okay, this is page 413. A, you'll also have to finish B. There's an example already given here, example 1, which is similar to what I have done, but it shows you in working how you find the MAD value and how you appropriate it in your answers. So you need to do this. Question number 2, page 215. Question number 2. Also, you'll have to go to the last to the section. Independent practice 15.1, do 7 and 9. 7 and 9. Page 418, question 7, and page 419, question 9. God bless you.